Welcome to FYI, the For-Your Innovation podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARC Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARC. All statements made regarding companies or securities are strictly beliefs and points of view held by ARC or podcast guests and are not endorsements or recommendations by ARC to buy, sell, or hold any security. Clients of ARC Investment Management may maintain positions in the securities discussed in this podcast.
From ARC Invest, this is FYI, the For Your Innovation podcast. I'm Brett Winton. With me today, I have Sam, who's our Director of Research of robots, reusable rockets, energy storage, all kinds of things that move around in the world and require like electrical energy to go. How's it going, Sam?
Good.
In our venture strategy, we invest in disruptive technology, which is why we have the likes of, OpenAI and XAI and SpaceX. And that's why we're invested in a stove company like Record Scratch. What are we doing here? Why are we invested in Impulse Labs? What's exciting about this company?
I really think it's not an overstatement to say this is the Tesla of appliances. And that might sound crazy to the average person, but I think that Sam is also the founder. Once people hear from Sam, I think they're going to really understand how profound a technology leap it is to put batteries into appliances.
Yeah, the overall appliance market, it's almost the size of the smartphone market. So this is like a non-small market, but it's filled with all of these kind of old legacy players with legacy technology. And Sam D'Amico, who we speak to today, founder, CEO of Impulse Labs, is going after that entire space with, it's an interesting, innovative approach. And when we first spoke to the company, I was like, there's no way this is going to be an interesting company. And in fact, it's fascinating. So enjoy the conversation. I hope everybody at the end of it at least wants to get an Impulse Lab stove installed in their house. And we will hear from you later. From ARK Invest, this is the FYI, the For Your Innovation podcast. We've got a great show with you today. We have Sam D'Amico. Did I even pronounce your last name right, Sam?
You got it right the first time.
All right. And of course, Sam, who covers, batteries and robots for us. So most people look at a kitchen stove and they see a place to boil eggs. Sam looks at a kitchen stove and he sees a place to boil eggs very quickly, and he sees the energy hub of the future of the home. Sam, how do you go from Facebook, Google, Oculus to I'm going to do kitchen appliances, and why on earth are you doing it, please?
It's actually a really good question. And it's remarkable how these are more related than they're not, which I'll get into. So for background, I started my career over 10 years ago working on Google Glass of all devices, and kind of got to see the end to end of how a consumer device gets made, from ideation all the way through to the factory and measuring things going on in the factory and making sure that your yield was good and stuff like that. So getting down into the actual weeds of production, and had similar experiences on a number of different programs at Google and Oculus and as part of Oculus getting acquired by Facebook and them productionizing the Rift headset. And I kind of realized towards the end of the 2010s that this was increasingly the realm of big company stuff. To kind of rewind, Oculus got started because one of the reasons Oculus got started was Palmer was experimenting, trying to build a VR headset I think it was a trailer in his parents' driveway or something like that. And at the time, a basically hobbyist person realized that, hey, I could actually build a really good VR headset with the parts that were just available from the consumer electronics industry. Basically get smartphone or tablet displays, magnifying glass lenses, etc. And he could almost duct tape together a better VR headset architecture than anyone had done so far. And then kind of go back to 2019 or go forward to 2019 or something like that. This became something where Apple and Meta and all the other guys, they were really starting to fine tune the display technologies, the camera technologies, all these other things. It was increasingly not the realm of like, someone could have a genius masterstroke on the architecture side and really innovate. So I was like, I don't think I'm going to be able to drive like new innovative categories of devices in this space. And I wanted to do a startup. So I kind of went looking for where in the consumer electronics industry there's maybe more neglect. There hadn't been as much innovation in 20 years. And at the same time, I was getting kind of obsessive about like cooking pizza really fast. And these sort of things fused together into one kind of great thing at the same time. And what that was basically, I realized that appliances were fundamentally power limited. And if you could embed a battery inside them, you could boost the power way above what like a 120 volt plug could supply the device. The initial use case I latched onto was cooking pizza like a brick oven. But obviously that's not the only thing you could do here. And so went from that to like, what is the device in the home where the fuel source is the user experience? And that happens to be your kitchen stove. That's the one device where if I say I'm going to change this from gas to electric, you might complain. And by targeting that first and making an argument not dissimilar from Tesla, where, hey, we're not going to change people's behavior by taking something away from them. We're going to change people's behavior by making something foundationally better. And that was the beginning of what became Impulse.
And you can buy the stove today. I can go on the website and get it.
I had that idea around like 2019 timeframe. And I guess it's 6 years later, you can buy the stove. So the second piece of this, I think, is actually really important, though. I think this is something that you talk about like the pitch of the business, all the other stuff, but there's actually a second transformation happening, which is every complex device is getting redefined around 4 key technologies. And I think this is like, obviously, to go back to like ARC's other portfolio investments and stuff like that, like it's pretty much a lot of the things that you guys have already been focusing on, which is like batteries, electromagnetics, embedded compute, and power electronics. And if you kind of look and see everything from like Tesla cars to consumer electronics, every single device, whether it's an iPhone or an EV, ends up being built from kind of the same fundamental technologies and coincidentally is often engineered and built in a similar way. Like basically like Tesla is very monomaniacal at controlling all the component supply chain of their device, of their car. They've customized all these components like up and down the stack. You could look at a smartphone and see the same thing. But there's this missing middle set of devices, of which include major consumer appliances, that has not yet seen kind of this technology revolution, also this like way of working revolution and how you build it. And so it's not just about putting the battery in the device. It's also about redefining how we build these devices as kind of a software-defined hardware platform and rebasing the technologies we build these things out of from, like around what I would call like the modern electric technology stack.
It is interesting. I was thinking about this today, and it's like each of those things you said is somewhat happening in its own cycle. And I was just reflecting on the Internet of Things hype cycle, right? Like there was a consumer electronics show where everything was, here's a fridge connected to the internet, here's your dishwasher connected to the internet, your dryer connected to the internet. And it's like that was not a success other than everything's connected to the internet. So that's good. But it's like, I think what you're talking about now, which I actually think is far more profound, maybe because it's stacking on top of it. But right, I think it's time for the battery of things cycle to really take off here, where it's like a stove with a battery is far more powerful than a stove that's connected to the internet.
Yeah, and actually that's a really, really good take. Like I would say that the other reaction like in 2019 that I had while kind of thinking of this idea was, well, there's all these kind of cool smart oven companies. I'm friends with some of these guys as well, that are putting connectivity in these devices and actually AI in some cases to like automate cooking and stuff like that. And you could go back to 2014, you go back to Juicero, you can go back in time and like as soon as basically you could put smartphone class electronics in devices, people did. But then in many cases, it was a solution looking for a problem. What I realized was, well, you're going to need all these technologies to make these devices work, period. That's like going to happen. But you need to have a performance rationale to pull forward these technologies, not just the technology is available and can be integrated, basically.
And so then what is the performance, right? Pitch us on the impulse stove. Why should I, I'm out here shopping for an induction stove, which by the way is better. Like I have one and it's, better than gas. Trust me. I mean, you get over the hump and it's better, but impulse is better than better. So what makes impulse better? And what did you have to do to make it better than better?
Yeah. So, I mean, I think to start, let me just define what an induction stove is, and then we can kind of go beyond this, because a lot of folks, especially, folks who listen to this, probably have a gas stove. You live in the coasts and things like that. So what an induction stove is, it heats the pan directly by generating an alternating magnetic field in a coil. If you've seen like a transformer outside your house on the street that turns like one voltage to another, like a high voltage to a low voltage, an induction stove is kind of like a transformer, but it turns it turns the higher voltage inside the device into a short circuit in the pan effectively. And then because the pan's high resistance and it's got magnetic domains that flip around and basically generate friction, it starts heating itself directly. So an induction stove effectively does not get hot. The pan on top of the induction stove gets hot, and thus the name induction. So what's great about this is you get direct control over the pan. So basically, if you send energy into the coil, it basically 100% of it gets into the pan, 90 something percent basically. This is awesome. It means that like compared to a gas stove where maybe two thirds to half of the energy goes out into the air as heat, basically you don't end up heating up your kitchen. You also don't have any sort of like gas byproducts like floating around inside your house as well. So all that's really great. And then the last piece is performance. So like you can get several thousand watts out of an induction stove today, usually around like 2,000 to 3,000, which typically means you can heat a pan, 50% faster or 30% faster than a gas stove in many cases. So that all sounds great. But then I'll get into kind of the details on like what we realized we had to improve to really drive adoption. And our realization is around that, like, we're a new brand. No one knows who we are. The only way we're going to get people to actually go and buy it, the product, is if it's like several times better on many different axes. And I can kind of go into what each of those are, because there was a couple. And then there's ones that people don't even know they need yet. And so, and we have to then go and teach them. So I'll start with like the performance side, which is, we were like, we should just be 3 times more powerful than baseline induction stoves, because if we can say that's like, we can literally do the 3x better situation. So what we decided was like, let's put 10,000 watts in an individual coil instead of like 3,000 watts. And what's crazy about that is because there is like loss to the environment from like basically, steam being generated on the pan, convection, et cetera. This means it's not just 3 times faster, it's like significantly faster. So instead of like taking 10 minutes for your 10 cups of water to boil, it's more like a minute and a half. And so I was talking to my friend who just got one of our units, and he's got it in his apartment in Manhattan. And he was like, I literally can make dinner in 10 minutes now because I don't have to wait for the water to heat up. It used to be literally the first 10 minutes of me cooking.
Wait, before you keep going, you settled on that power. How high did you push the envelope in testing before you're like, okay, let's dial it back to something reasonable?
I think it was actually, I just asked for an unreasonable number and the team delivered it. And so the other piece of this is there's actually a couple limits. So we'd actually tested it like 12 or 13. We probably could push a patch to customers that brings it to 11 to like Spinal Tap reference. Like the system likely can handle that. You end up designing the electromagnetic system, including like the coil and some of the other stuff around these certain design points. So it's like you kind of pick a maximum and then kind of size everything appropriately. But yeah, there is actually margin beyond that. There's the actual limit, which I determined through some other testing, is driven. It's actually, if you've heard your nuclear reactors going to meltdown, the primary cause would basically be that the fuel gets so hot that the heat flow into the basically the heat flow around like the fuel rods or whatever is enough that basically there's just 100% gas around the fuel rod. So there's no water to convectively cool it anymore. Basically, it's like there's gas which doesn't have an upper limit on what its temperature can be. And then you could have steam at 3,000 plus degrees and then nothing melts. And so the similar effect happens if you actually set a pan, you put enough power into a small enough pan, you can essentially have entirely gas film on the bottom of the pan, and then the pan gets red hot. So obviously you want to avoid things like that. I believe that number is probably in the 15,000 watt sort of zone for kind of some practically sized pans. I've been able to generate this with kind of an undersized pan as well. But that actually takes us to the second point, which is like, how do you keep this higher power safe? And we realized that this is something that is very challenging. A lot of induction stoves are just flat glass. So what they'll do is they'll have like temperature sensor behind the glass as kind of emergency cutoff, but like that's not a very fast system if you've decided to dial up the power. So to make sure we can actually handle as much power and keep the system safe and realize like, oh, you have a dry pan or something like that, like don't overdo it. We had to invent a much faster type of temperature sensor. And that basically required almost like a science project. We ended up pulling in like a physics PhD type person to help us with this. And it was like starting on that end, and we had to basically bring custom components all the way through the supply chain, like custom ceramic components, different types of thermocouples that had never been used in stoves before, et cetera, and build that into a temperature sensor module component that was frankly like a 4-year project in and of itself, separate from the stove, just to make sure that we could support this high level performance. And so coincidentally though, I was separately looking on product modifies of like just cooking, and I bought a Breville Control Freak, which is one of the only temperature controlled induction stoves you can get. And I was using that as my daily driver and making tons of different dishes with it, sous videing on it, et cetera. And realized that like the future of induction was not this like, if you think of a stove today, you basically have like a tachometer control where you control the throttle, but there's no speed control. There's no like there's no cruise control. And so by virtue of being able to set and hold an exact temperature, you now dramatically simplify what it's like to cook. It makes cooking more like baking, because instead of saying, set it to medium high and then turn it down to medium low when you're making eggs, it's like set the pan to 315 and your eggs always come out crispy.
It's like I have this problem where I need my eggs to not stick on my stainless pan. And I know there's a pan temperature where that's true. And I kind of know how to dial it on the induction stove, but it depends on the pan size. And it depends, like there's all these variables I don't actually know. And so sometimes I do it right. And sometimes I'm like scraping egg off of the pan. You can conceivably solve that, right?
We have solved that problem. And actually, if you have a stainless steel pan on the stove, I've done demos for people where you can set it to about 380 or 390, which is like a temperature where like if you throw water onto it, you'll see it kind of dance around because it's like riding on its own gas. And if you do it, you can actually crack an egg on a pan like that and it won't stick even with no oil in the pan, because the gas bubbles will essentially keep it unstuck. And so I've made eggs like that and the bottom looks like a pancake. It's kind of funny.
This is really getting to the real business model, which is the precision cookbooks that are going to go on sale.
Well, so this is where I think actually if you can tie, there actually is an AI angle to this, which is like straight up, if you've got a very repeatable system that is like measurable, you can start giving people better instructions for how to cook. And we have users that tell us like they use ChatGPT to cook their dinner now, because basically they mention they've got the stove, it gives them the correct temperatures. There's enough temperature controlled cooking data that's like out on the internet that goes and finds, and they end up getting good results out of it. But yeah, I actually think that the big story is really like, if you can turn cooking into more like baking, where if you follow instructions, you get good results, it means that like this is a much less stressful thing, but it's also that like we've solved the core automation that makes cooking hard. And we did it without having to like really overwhelm people with like tons of new information, right? And that is like just set the temperature basically.
Or even it's like on the smoke point of different oils. You can be like, here's the way to not absolutely burn your olive oil.
Yeah, and I could like fry a steak in olive oil and it will sear well, and the olive oil will not smoke. I will shout out the Brian Johnson snake oil olive oil has a relatively high smoke point, so that's a good one to use. Not that said, he is like he's shown he's vegan, so it's kind of ironic as part of this, but the oil is good for making steak. I'll say that.
Okay, so that's at least a couple of the magic things you put into the stove to make it work. And it also illustrates how it's kind of, when you're kind of advancing the cutting edge of technology, you also have to be building your own components on multiple parts. You can't just attach a battery to actually deliver the performance differential that will get people to buy the thing. And us as investors, we're not just interested in a stove company, though I love stoves. Like why? The battery itself is also useful. And like, to what use could I put having this battery other than cooking the perfect egg?
Yeah. So, I mean, and the goal here is like the stove use case is kind of the bait to get the battery into your house in some cases. It's like if you're thinking of like a Trojan horse analogy, you're going to get this thing because you want the device because the device is higher performance in many cases. There's also an installation benefit, which is like, because the battery provides the boost power, you can trickle charge it off of any plug, basically. So you can install it on 120, 240, et cetera.
Meaning you could kind of like put it in yourself and just plug it into the wall rather than having an electrician do a 240 volt and he has to like upgrade your sub panel or, so it actually lowers cost of actually acquiring pretty substantially.
Oftentimes that's like someone will be like, I want this product. And then they find out there's a veto point and it's like, we got rid of that veto point, basically. I would say that there's a couple things to touch on, which is like, yes, the component engineering and making sure we actually own the whole stack was a huge undertaking and like kind of a key piece of the strategy. Because basically if you look at how appliances are made today, they're made more similarly to like Ford automobiles than like Tesla, where like Ford doesn't necessarily have to specify every underlying piece. They may buy stuff off the shelf from folks like Magnetic Content, other things like that. Tesla, on the other hand, goes to a lot of the same vendors in many cases, but like they're customizing everything all the way through. Like every last component has Tesla engineers' fingerprints on it. And this is important because it means that like they can own the whole end-to-end user experience. In our analogy, it would be everything from that knob turn and like the magnetic knobs that we developed ourselves in-house to the induction coil, putting energy into the pan, to the sensor, understanding what that temperature is and feeding back to the system, to the display and the software and everything that we can run on top of it. We control the whole experience. And so that's all in service of getting this device into your house. Now, once it's in your house, we've snuck a battery into your house, and we can do a lot of the same things that all these energy storage companies can do, just at a slightly smaller scale. Obviously, this is not as big as a Tesla Powerwall. It's like a quarter the size of a Tesla Powerwall. It's like an eighth the size of like the systems that Base is putting into people's homes in Texas. It's not necessarily the biggest battery in the world, but it is a 3 kilowatt hour battery, which is relatively large. And for context, I think it's like the average draw of a home in the United States is about 1 kilowatt. And so if you have a 3 kilowatt hour battery and there's like a 2 hour long grid emergency where they're like, hey, everyone should start reducing their load of their house, we can contribute to servicing the grid basically with this battery and get paid for it. So it ends up being something where, unlike the smart appliances of 10 years ago, where there's a subscription service or something like that, we essentially can give people peace of mind, like it works in an outage, they've got all the other things, but also it can contribute to the grid and get paid by the utilities. And we can essentially have this long-term relationship with the customer that's not adversarial because we're doing something that helps their community. We're getting paid not by them, but by their utility. And there's a lot of just like interesting synergies where this makes the device, like our incentives are to keep these devices in operation in perpetuity versus hoping that a repair guy comes and buys expensive parts from us, basically.
Well, then it's not just helps their community, it helps them. I mean, in some ways, it's like you buy the stove, but you get if on the cost per kilowatt hour of a Tesla Powerwall, kind of a $3,000 battery or something free, effectively. Maybe not 3,000, but like 2,500, something.
Unlike the Powerwall, it's like the Powerwall is great. Sure, it gives you lots of benefits, but it's like the stove gives you extremely tangible, incredible upside in using it with almost none of the downside, because it's like, even if you're a chef, like let's say, and I say chef, you're a home chef, right? You're cooking for your family. It's like you're using it for what, an hour and a half a day, right? So it's like you get the performance uplift, but really you're not using it all that much.
But the battery is contributing basically to your energy security 24 hours, anytime there's an outage. So it actually makes the capital that you have sitting in that stove actually better utilized because it serves as this insurance function for you.
And for folks who haven't looked at our website and seen our pricing, it's like we basically price these things like the same as the like kind of luxury product, like stoves, like so like Miele, Gaggenau, Thermador, that sort of stuff. And so effectively, you're not spending much more, if anything, than you would if you're buying a Wolf or a Viking or a Thermador or something like that. You get all of these capabilities that are just fundamentally different because the device has been re-engineered from the ground up. And then the battery storage stuff is the icing on the cake. And like, this is also a really, if you look at how other battery storage companies market their products, it's like Tesla sells Powerwall predominantly through solar, where people get solar because they want either energy resilience, or they want cheaper bills, or both. You see how Base has been marketing in Texas, and it's primarily a backup product where it's like, hey, if the grid goes down, you've got this thing, you got it covered, and your rates are a little lower. But understanding that your rates are going to be like 10% lower, maybe sometimes some of the time, that's less of a good pitch than like the backup thing. And then we think we've got a net new pitch that is like the devices are fundamentally more capable and they're redefined around kind of this modern electric technology stack. And that's why you really want to buy them. And coincidentally, these energy system benefits come out of it.
But that's also a real thing that people otherwise pay for. So the fact that that's like a add-on for free, I mean, if you think about it, it like if you have a Powerwall, it gives you 25% more Powerwall without having to pay more. And you say devices. So are we just looking at a stove company here, or what else could you possibly do with battery attached power electronics into home appliances or elsewhere?
That's a great segue. So like our belief from the beginning has been that this is a multi-device company. One of the key strategies that's helped enable this is, well, first we had to build the first one, which is kind of, there's like a 0 to 1 problem of like, let's show that we actually can do it. And Stove's a great example for doing it. Like you think of it like kind of like a Tesla Roadster sort of example of like, let's show that we actually made a better device than everyone else. And like, this is clearly true.
I think if it was the Roadster example, the stove would cost like $25,000. Instead, this is more like the Model S.
Yeah, I was actually told to consider doing that. Someone who is I think they were like a seed investor at a small amount, but they're at a very big, very big firm. Was like, yeah, you can make this thing cost $10,000 or $20,000 because it's that's the actual one. Now we think that there's other reasons to make sure that it's like right down the mainstream. But the other part of this is, how are these devices actually sold, and what's the channel, and understanding that. So like what we've been doing on strategy side is, now that we've got this really awesome device, we bring it to other appliance companies and show them that like we have fundamentally new technology, and we're offering kind of the underlying platform to them, like the entire electrical stack for them to actually go and integrate into their own products. And that lets us solve a couple problems. First of which is, I don't want to be in the business of making 5 different types of stove and like 50 different types of major devices, basically. Like I think it ends up kind of becoming a scope explosion, not just scope creep, but scope explosion, where it becomes really difficult for a startup company with like, we're still under 30 people to actually go in and manage kind of all of that complexity. And if you then look at other appliance companies that do have to do this, they don't have a lot of space to do kind of new innovation. So it's sort of this trade-off between like, do you fan out with like a relatively, without having the technology, and essentially you have to get really good at marketing and like the channel, but you get really good at showrooms and all sort of stuff. Or do you go really deep with the technology and use that as your wedge? And so we made the call to basically partner with a lot of other large appliance companies, embedding our technology into their products. The first, we've announced partnerships with two of these guys so far, one of which is Thor Kitchen and the other of which is Zephyr. And we're really excited about that approach because it means that basically we can solve the channel thing and some of the like SKU or stock keeping unit for the folks that are not like acronym poison like I am. Like you don't have to have too many different versions of the product basically and manage all that complexity. So really excited about that. But then with that strategy, we're then able to basically enter other categories beyond just stoves and ovens and other sort of cooking appliances. So I can kind of go into like where we see the benefits. And frankly, it's kind of like if you go in your house and you see what appliances often come as gas appliances, that's a good first hint. So this is like HVAC is a good one because like spinning up, you need a lot of starting power to start the motor or start the compressor for an AC system, and having a battery built in means it doesn't need as be via wiring to the rest of your house. Water heaters, they literally come with tanks, and you can kind of look at this where like, well, they already have energy storage. This is just a different type of energy storage. Ovens, pizza ovens, obviously I'm interested in stuff like that. Laundry machines, a lot of the ones that dry fast run on 240 or are gas. And so you can kind of go through and there's probably like 4, maybe 3 to 5 slots, depending on how you count it, where you could put a 3 to 5 kilowatt hour battery relatively easily inside the device without changing its form factor, without changing anything really about, how it fits in that given slot. But that would then dramatically reduce the electrical requirements of the device and improve its performance. Like your clothes come out faster, your refrigerator could be more quiet, etc.
I was thinking about particularly the water heater side. It's kind of like, even if you have a tankless water heater, you have like a gas hookup to something that's like pumping the water through. And you wouldn't want like the gas igniter to sit inside your house. But like conceptually, couldn't you have like at the shower head, like a little micro water? It doesn't even have to have a 3 kilowatt hour battery. Maybe it's lower, but you're like basically heating the water right at the spigot source. And so you have like a distributed set of water heaters through your house rather than one big one. Or is that just insane?
I like that idea and where you're thinking. I think we'll in that sector, we'll probably share more. We'll probably share more in the coming years on what our exact strategy is on the water heater side. But I do think that like, I'll give another example of where that exactly is already done, which is in places like Brazil, they have this they have these, the shower heads have direct 240 volt or 230 volt wires coming into them. And I think some of those do actually, so some of those actually that product exists in places where there's, let's call it higher power electrical distribution in the building already, if that makes any sense.
I mean, because people already pay for it. They pay for like hot water circulators and stuff, so they get instant heat at the shower head. There's clearly like just sitting there waiting for the shower to get warm. It's really annoying. I want it solved. Please solve it.
Or it's like anywhere where higher power, right? Because it's like you're saying, just the replacement and efficiency side of it, but also just anywhere where you can, 5x the power and that yields interesting results is going to be a fun new home appliance.
And I think there's like 3 to 5 of those devices in every home, if that makes any sense. And then there's a commercial aspect of this too. Obviously, commercial kitchens were a great example. Like if you're in San Francisco or New York, you're probably in an old building with that probably doesn't have like beefy 240 volt circuits ready to go for like induction wok systems or other things like that. Meanwhile, like we've already been talking to commercial kitchen operators who bought our units, like just because they want the temperature. Well, they want it for like the temperature control and some of these other reasons, but like they can install it and there's no electrical constraint. Unlike with installing like a 60 amp induction cooktop or something like that in there.
Right. I imagine that's also good for standardization, right? It's like maybe even not fast food necessarily, but at like any franchisable place where it's like, hey, we want quality control across the whole spectrum could be quite useful.
Actually, if you think about it, like the reason boiling water is like an easy operation for people is because once you have water boiling, you have a constant temperature that you're like putting the food in. So if you can
only
do
if you're at the same elevation.
Well,
that's why everyone in the Rockies is just terrible pasta.
Terrible cooks.
That's why we have a barometer in the product for this reason.
Nice.
Oh, interesting. Do you think philosophically it's kind of like having one large battery versus a lot of smaller distributed batteries? Shouldn't the world move more towards distributed batteries rather than one large battery? And are you limited to the kitchen and the household with this strategy? Could you see branching out elsewhere into the commercial industrial world?
Yeah, no, I think those are great questions. So I think like basically if I was to describe, I think the electricity system is a network like the internet is. And one thing of the internet is it has buffering kind of every phase. So every stage. So it's like, there's like packet buffering on your computer. There's packet buffering at the routers in your building. There's, every layer of distribution, there's actually like some form of buffering to make sure that like throughput can be maintained. A analogy for folks that are less steep in computer science textbooks would be the water distribution system. And I can use kind of a funny analogy because I make a toilet joke, which is if you look at like the water distribution system in California, where like we have Hetchy Reservoir, that's like, you could describe that as like, that's a power plant with an attached battery storage system effectively. And then you've got like a big water pipeline going to the city of San Francisco. And then at the end of that pipeline, there's probably a storage tank for the water treatment system, like sitting there. And that's another big battery. You can think of that as like a substation battery hanging out outside of a neighborhood or something like that. And then that then goes, to distribution to the various neighborhoods. And then inside people's toilets, they have a toilet tank. And the reason that's there is because when you hit flush, that is more water than your house normally needs to sip to maintain, it's more throughput than you would otherwise get from the pipe into your house. And likewise, the tank for your shower, the water heater tank, is also sized for kind of capacity for that reason as well. And so we actually have built buffering at every phase, whether it's the device side, which is like a toilet, the home side, which is like the tank water heater for your shower, or the utility side, which could be like the reservoir or the water treatment system holding tank, basically. And so we've already kind of looked at this where, like, if I was to say, like, okay, are you going to win versus like home scale batteries? It's like, no, I think we're going to have all of these solutions just because of the nature of the way this network works, basically. So that's the first kind of part of it. And the second part is, I just strongly believe that you can make better devices by rebasing them on these new technologies. And if you have a built-in battery in a device and you can run directly off of the battery voltage with a very close connection to the battery, you just have more power available to do stuff. And you then don't have to resize all the legacy wiring in your house. You don't have to get permits. You don't have to really do anything. Like, the device itself controls its own destiny from the power system, basically. It can charge from the grid when it's cheap, clean, and abundant, and then the end user can use it whenever they want. And this means this decoupling of power input or device energy input from device power output and device performance is one of the things that lets us make better devices.
And I think that's true, at all scales, like you said, right? It's like, it's great at the home because you don't need to get a new circuit board and all of that, and an electrician who's going to charge you a ton. But same thing, right? We see it with Tesla too, at supercharger stations, or even for like what they're going to do for the 70. It's like you put giant batteries there so that the grid infrastructure doesn't need to be upgraded as much, and you just, buffer it yourself.
This is also true for like spacecraft, like SpaceX going to all electric actuators versus hydraulic. Like, basically, I have like the other spicy bit of the take. There's another spicy take you can derive from this, which is like the next generation of military vehicles are all going to be hybrid electric at minimum, because the power density you can get out of a battery is just better than what the legacy like diesel generator type approaches can get you. And it's going to be something where everything will go electric for performance reasons. And oftentimes when it goes electric for performance reasons, the performance is derived from an embedded battery.
But would you stick Impulse Labs battery power electronic systems into a vehicle, you think? Or you think you're a stationary only solution?
So this actually goes into like where I think our strategy is, which is like, there are kind of, I would describe it like there are dominant providers on the small devices side. So like you think of like Apple, and then you can think of like, at least in the United States, like Tesla on the vehicle side. I think there's this missing middle that, and this goes back to what I said earlier about like Palmer Luckey realizing that he could go and like basically make a VR headset out of cardboard and like off the shelf phone parts, realizing that there's this missing middle of neglected devices that we can essentially reinvent around a new technology stack. And I don't have to compete with, frankly, Tim Cook or Elon, which I would be kind of afraid of doing either. And I think there's a wide open swim lane here where we can make really awesome stuff. And it's a giant market that means I don't have to necessarily go into the automotive space and compete with some of these giants just yet.
And it also has the benefit of, it's like the energy storage becomes such a value add to this particular end user. And I have power walls, and I swear it's so useful to not run out of power. And, for a long power outage, I'm like, oh gosh, I have to run around and make sure different appliances are off to extend it out. It would be nice if those appliances would just be like, no, I got it. I'm good over here, and can continue to operate for me. So,
and your inverter in your power wall can be smaller because you now don't need to support a 60 amp stove load if you turned everything on a normal induction stove. So like, it actually means that the rest of the systems, including the whole home batteries, can work better. And maybe even make them easier to install, like kind of in the end, because like, oh, you don't need to do this like critical load panel thing. Like a lot of times the kind of Powerwall installs, they get way more complicated on the install side than on the actual Powerwall side. Like you're like, okay, a Powerwall is like $1,000 per kilowatt hour of battery storage. And then it's another $500 per kilowatt hour of installation, basically, of like getting an electrician in, all the ancillary stuff you have to do to make that happen.
Okay, so now you're on the cusp of, I think people are going to buy your stoves. People already are. People love them. You then have to actually scale up manufacturing the stoves and whatever other amazing kit you're going to build. I guess you've been through it before, but talk to us about how you even prepare for kind of the manufacturing scale up and the challenge of execution there.
So there's a really good Elon quote, which is like, the factory is the product. It's like in a tweet. It's in a tweet. And it was like a tweet reply to, I'm not even sure if the original tweet exists anymore, but basically someone asked him about, it was during Model 3 ramp, probably when he was sleeping on the factory floor. And I resoundingly believe that statement. And the way we approached this business was, let's figure out how to make the new technology. And then as soon as we possibly can, let's go talk to manufacturers that we know can scale it. And then make sure that we co-develop kind of the next prototypes of the system with the production process so that you're effectively playing for keeps, as I would say. So like basically when you go and make changes to, say, our temperature sensor or things like that, those changes are informed by an actual supply chain. They're going into parts that are tooled, like all of that sort of stuff. So because we spent the past 4 years basically on that journey, we're in a very, very, very good spot in terms of like tool production with decent yields of the current cooktop product. And it's being made by scaled partners that you may have heard of, and you probably have bought products either branded by them or manufactured by them. And so we're very excited that we're actually able to kind of turn that crank now. The approach we took, to be blunt, was we had to look to folks that wanted to work with a startup. And so that invariably routes you to Asia, especially if you've got kind of my experiences and connections. That would be the smart way to go. If I had any sort of regrets, it would be that China opened up a little faster from COVID. But basically, we spent much of the last several years kind of building out that production capability. A lot of what's, obviously, a lot of what's gating us now is actually more like just like working capital and other things like that, which we've like recently been able to address. And it's actually like you end up having to bulk buy materials in larger and larger volumes, and that ends up pushing costs down. Oftentimes the volumes even compensate for like increased tariffs or uncertainty on like China versus Southeast Asia versus other things like that. So a lot of it's been just an exercise in turning the crank. And in order to do that, that's where some of these partnerships have come in really valuable. So like we're really excited to be distributing units through Zephyr, for instance, and being able to have kind of reliable sources of large demand for product means that we can really drive kind of costs and margins up, or costs down and margins up because of these partnerships. The other thing is like, it's been exciting. And also I'm very thankful to like our pre-order customers. We opened pre-orders in like January of like 2024. And folks have been getting their stoves over the summer, and I'm really glad they've been patient for, like the 18 months or so that some of them have been waiting.
So on it, what is the kind of like top line? Is the right KPI to think of for Impulse measured over a few years is number of kilowatt hours like sitting in homes? Is that like ultimately, if this is just basically to infiltrate energy storage into all of these homes, is that the right way to think of it from a very top line perspective? And what is like the future vision? Yeah. Where are you going?
There's a couple different KPIs, and I think this is kind of an interesting, that's a very interesting way to frame it, which is like, can we get to gigawatt hours of deployed battery storage built kind of invisibly into these missing middle machines, basically? I think that's an awesome goal. And it also means that the grid gets a lot more resilient as well. We also straight up see that like redefining devices around this new technology stack and the total number of devices that we're pushing out through that is another really big metric. And like, that's something that I'm very much tracking, which is like, how broad can we go with the smallest amount of unique new modules, basically? Because it's like the idea is like, can we stuff the exact same battery and the exact same inverter and much the same power electronics in as many different sizes and shapes of appliances as we possibly can. And I think being able to realize that sort of leverage, and with the goal in mind of being kind of like Intel saw success here with Intel Inside, and Intel did not have to go make every last shape and size of desktop computer with Dell and HP and whatever and all the other guys. So I think that there's a lesson from that where like if we've got the Microsoft plus the Intel, like we've got the software stack that and the management of the batteries, the power electronics, software stuff, and we've got the underlying hardware widgets that go in. There is a horizontal expansion play where we can kind of keep our scope relatively under control, but end up redefining millions of devices this way.
And then if somebody has multiple of your devices in their home, then there's probably some software layer where they get access to the underlying power storage they have that's kind of impulse controlled, right? Yeah.
Yeah. Every single one of so basically our target is that we build a compatible ecosystem even across brands we partner with.
So I think it is very fair to say it's the Tesla of cooktops.
The roadster strategy is apt, and I would actually argue that Tesla was genius. If you go back in time to one of the original Tesla master plans, they're like, we're going to build a fast car, then we'll build a slightly cheaper mid high-end luxury car, and then we're going to do this. The strategy that I thought was really genius once I plugged into it was, we're going to build this really fast car, and then we've got this awesome power electronics, battery, and electromagnetics platform that we're going to offer to all the big car OEMs. And we're going to get deals with Daimler and Toyota. And we're going to start launching a powered by Tesla, Toyota RAV4. Obviously, that did ship. And that was what powered them through their IPO. And then obviously, they managed to be so successful at fundraising in public markets and getting partnerships with like the US government and other things like that they didn't need to run that strategy anymore. But there was actually a world outcome where Tesla looks more like CATL, where they're building the underlying like power systems platform, battery platform, than it is where they're this like vertically integrated, what I would describe as like a robotics, AI, and energy company, basically.
And so I don't know the answer to this. What happens if you just like 10x the power of a microwave? Does that do anything for you?
There is a YouTube video of this you should go check out. Maybe you can link it, but it's maybe you get in trouble for linking it. But this guy StyroPyro, who's a total character, he makes like a 10 kilowatt or 20 kilowatt microwave. It depends on what you were cooking. So when you cook like a hot dog, it appears to just take less time. Like it appears just to work, which is kind of cool. It's kind of like what we discovered with 10 kilowatt induction. It was like, it just works. The funnier example was I think he puts like a cup noodle in there or something, and he just ejects the cup noodle because the outside of the cup noodle turns to gas, and the gas on the outside pushes it out of the container, and it makes a mess. So I have a funny story about this. Is a close friend of mine replicated this one time when he was he worked at like a metal shop, like a research lab that did like high temperature metallurgy or something like that. And they had a microwave for heating samples. I'm not going to sure what the context was. And I think he did exactly this and made a mess and had to clean the thing up. And it was a disaster. So yes, you can do it. I would not recommend putting water or soup in there. But apparently you can turn microwaves up into power, which is maybe a hint for things we could do in the future.
Yeah. Very interesting.
Yeah. Or maybe dry clothes very quickly or something.
Yeah, I think there's some really fun ideas in terms of laundry and other things like that. Like I get, what's fun is my DMs are always full of people with good ideas, and we've taken them up on some of them.
Nice. Okay. Well, so and also at a high level, like the home appliance market is like basically the size of the smartphone market, right? I mean, this missing middle of kind of like set of devices that currently a lot of them have the same performance characteristic they've had for 50 years or something.
And the same as their peers too. So like what's happened in this industry is I would describe it as like there were like thousands and thousands of showrooms and retailers and stuff like that across the United States. They obviously all have inventory of appliances, and you have to get into these showrooms. Like one of our team members founded a major appliance company. He was like, it actually took a very long time to get even to 500 showrooms across the United States. I mean, and we realized we realized this is like a very tricky problem to solve generally, because the distribution networks are kind of like opaque, relationship based, et cetera. Now, what's funny though is like if you go and tear down a GE appliance or a Miele appliance or a Bosch appliance or whatever, they end up sourcing a lot of their parts from some of the same suppliers, because these companies are actually really good at branding and distribution. Like they're legendarily epic at that. They're also really good at managing, like having 100 different versions of their thing, but they are not power electronics or battery companies at all. Like they have a lot of mechanical engineers. They have a lot of mechanical engineers in most cases. And so that's been something where, I mean, obviously I'm a newcomer to this industry. My beginner's luck happens to be that I brought kind of my like consumer electronics and some power electronics, team members and stuff like that to bear on this problem, which is not a typical team that ends up starting an appliance company, basically. And that advantage has given us the ability to really be complementary to a lot of the partners we brought.
Well, we look forward to, I want my home full of Impulse products, so you better ship quickly.
And by the way, if you want a stove, it'll ship. I can get you a stove next week, so that's no problem.
Okay.
Yeah. But Sam, can you take us? I mean, I feel like we can officially call this the appendix of the podcast here. But take us through the pizza cooking journey. What was the best method, and what is your side project once Impulse is humming and in all appliances? You're going to come out with the brick oven equivalent that you can plug into a normal outlet, and what is it?
I'll give you the story of this. This was, I was in Japan of all places, and then of course I'm an Italian American guy claiming that I got really good pizza in Japan. Sounds like high treason or something like that. But basically, I'm in Japan. My pizza comes out. It's the place called Savoy Pizza in the Zabujuban. It's a great spot. Pizza comes out in like 30 seconds or something like that, because they've got this crazy hot brick oven. And the way a brick oven works is they disable fire. Fire heats essentially a ceramic kind of dome. Ceramic dome focuses that infrared light onto the pizza. And so the pizza is actually heated by radiation more than it's heated by conduction or convection. That kind of put this bug in my head where I'm like, okay, well, how do you replicate that with tabletop device? And I was like, let me just start buying infrared light bulbs and like LFP batteries and see what I could do out of this. And then I also was biting off too much I could chew with. Like I started a new program at Meta, which was the Quest Pro controller. Or this was called Facebook back then, but basically it's the Oculus Quest Pro controller program. So I got a little busy with that sort of stuff. And then the pandemic happened. And then I realized that like Impulse should actually just be, we should do a stove first. So I never ended up building this, but I have all the parts for it. And the realization was infrared light onto the pizza, and you get a giant pulse of light from the battery to support it. And thus you can see some of the origins of the name of the company and some other things from that original scheme that I had. There's a second part of this that's really funny, which was in order to start understanding how to build pizza, I was also hanging out on like bankruptcy auction websites in Silicon Valley. And so I still have two of the Zoom, like ZUME pizza, like automated pizza ovens in my basement. And I have those like for teardown purposes to kind of study how they worked. Obviously, they don't work anymore near what I was kind of expecting here in terms of like a infrared based system. They're much more of like, they look like commercial pizza, basically. I do have some of those in my basement, which is kind of fun. I might figure out a way to resurrect them at some point. But those ovens are cool because they mount in like server racks. So I could actually make like a pizza server rack or something, which would be a fun side project at some point.
Yeah, if you're really going to vertically integrate, then you would launch a Domino's competitor with your new pizza technology. It's like walk in and get a fresh cooked pizza.
They have the patented pizza tracker. I'm not sure how I can compete with that. So
Domino's is a real fintech mastermind player.
I regret not buying more. Once they fixed their pizza crust, I should have bought that stock. That was just a giant mistake on my side.
All right. Well, Brad and I are volunteering ourselves for the pizza party. When you choose the weekend to make the Impulse pizza oven V1, I don't know how much help will be, but we'll certainly taste the pizza.
You will taste the pizza. Okay, yeah. I will let you guys know when we got some prototypes.
Great. All right, Sam, thank you so much for coming on the podcast. It's been a pleasure talking to you. Look forward to the future of Impulse. And everybody can go on their website. The ovens, the stovetops, they're really remarkably well-designed pieces of kit. Like, you can see why people love them. And, even just like the magnetic knobs and everything else. This is like transforming the household into a place that's modern rather than archaic. So, good execution so far, and may you continue to execute and expand.
Thanks for having me on.
ARC believes that the information presented is accurate and was obtained from sources that ARC believes to be reliable. However, ARC does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from ARC. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARC's current views and assumptions, and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.
Thank you for listening to this episode of FYI, the For Your Innovation podcast. If you enjoyed this episode, please hit that like button and make sure to leave a comment down below letting us know what you thought. And if you haven't already, please make sure to subscribe to the show and follow us at ARC Invest on your favorite social platforms so you stay up to date whenever we drop a new episode.